Everybody, and welcome back. So today we're going to be finishing up chapter 1 and focusing on converting between different systems of units. So hopefully after today and after the next few videos, you'll be able to figure out how to use significant figures correctly and actually know what those are, understand the difference between the different unit systems, and also know how to convert between them. So let's get started. To begin with, we need to talk about numerical accuracy. Now, no answer can be more accurate than the data given from a problem. So, if you do that, you're giving a false image of precision that's not warranted. Like, for example, if I have a ruler, okay, and here's my ruler, and it has inch marks on it. Let's just say it just has inches on it. So, 1, 2, 3, 4, all the way down the line. And I'm measuring something. I can't say, well, this is 1.625438 inches long, because where did I get all these decimals from? Like, I have got 1 and 2 and 3 here. I don't have 0.625438. About the best I can say is like 1.5 if it's in the middle somewhere. Okay, I can eyeball that, and that's still an eyeball. The precision of my ruler is not nearly that precise. I would need to have a very, very good set of calipers if I wanted to have that kind of precision. So you have to be careful that when you're giving an answer in a problem, you are not giving way too many sig figs. As a note, the number of digits you give, that's sig figs, because it's unwarranted and it's more or less lying. Okay, now here's an example. Let's say I have a volume of a container and it's roughly 58 meters cubed. I need to fit boxes which have a volume about 7 meters cubed into this container. So, that's not too hard of a problem. How many boxes could I fit in that container? Well, let's see here. The easiest way to do this would be in the number of boxes. Okay, we'll just say number is going to be equal to 58 divided by 7. And if I plug in my calculator, I get this value right here. 8.285714286 boxes. That's a whole lot of sig figs there. But remember, I had two really important words inside of this. The first was about. It was about 7 meters cubed, and the container is roughly 58 meters cubed, okay? So we don't know how precise that is. Is it actually 58, or is it 58.7? Is it 59? Is it actually 7 meters cubed for each of these boxes, or is it like 6.5 or 7.5? We're rounding some. That's what we're doing there. So are you really 100% sure that many boxes will fit? And also, if I'm talking about how many boxes I can fit, I don't ever want to have a fraction of a box. Think about that. Do you want a fraction of your computer to be... Okay, maybe that's a better day. A fraction of a TV? Oh, well, we can only fit 10.5 TVs inside of this van, so let's cut the last TV in half. You don't do that, okay? That's just a bad idea. I don't want to come get a TV that's been glued to, or duct taped together in the middle. That is not going to make me happy. So we need to find a way of talking about numbers where we're being accurate, but also being honest about how precise our measurements are. So let's talk about significant figures, and then we'll stop for here. So our previous problem, the correct answer for an engineer would have been just to say 8, okay? It was 8.28. I'm going to round down because 8 makes sense. Now, if we're going to understand why, we have to talk about significant figures. So significant figures, or digits, I will go back and forth when I talk about it, is a measured number that's thought to be accurate. And it's based on the number of digits shown. So if I say 79.15, I'm saying that that's much more accurate than somebody who just says 79. Now, in our previous problem, we were given two quantities, 58 and 7. Now, if we look at these two, the first quantity has two significant figures, 1, 2, or two significant digits. The second one has just one significant digit. And so when I give my answer, I can only give an answer that has the same number of significant figures as the least accurate value I'm using to calculate it. So, it's like the chain is only as strong as its weakest link. In this case, my calculation is only as strong as its weakest significant digit, or least precise measurement. So our answer should have only had one significant digit. So instead of this long number, that was way too much, we should have just had 8. Okay? You see what I'm getting here? This one was 7, this one now becomes 8. Now, trailing zeros are not significant unless they are to the right of the decimal point. So 4800 is technically two significant figures. 48.00 though is four significant figures. It's saying that you're giving these two values, you're doing that on purpose to show that your answer is more precise than it otherwise would have been. In this case, you're not necessarily doing that. Okay, so let's stop here and then we'll do a concept check next time. Thank y'all for listening. See y'all in a bit. Bye-bye.